Warm welcome from Germany to the screens. Great that you are here. My name is Chris. I'm the responsible product manager for automotive. So what we're going to see today, it's all about what we have developed more or less in the last 10 years. Today it's pretty cold here in Germany, -4 degrees I've seen in the car. So I hope it's much better at your place. But today we're going to talk about automotive. And for the first, it's pretty important that you please all mute your microphones and your cameras. Then you will have a better internet connection, better performance. We have an active Q&A section. So that means when you have some questions, just throw it in, type it in. My colleague Della will take care of it. And we will answer all the questions during the training, during the webinar, or at the end of the webinar. So just write in, type in all of your questions. Everything or every question will be saved there and nothing will, we won't lose any question from your side. Today we're going to talk about the automotive trainings concept from Lucas-Nuelle and also a little bit with the input of the IMI. So the IMI is mainly about the automotive qualification. So that means that you can add and you have like, some unique points, unique benefits there that you can add to the training systems, even an automotive qualification. So that means you don't just have a training center. When your students run through the training center, through the different tasks, by the end of it, they can do an end test, a final test, and get the qualification for it and get different qualification inside the automotive area, while we are focusing right now the hybrid and electric vehicle section for these qualifications. But at first, let's start with the general concept of LN. So what is the automotive concept here? We have basically 3 different levels in the automotive concept. So we start from zero, from scratch, what we do with the unit train systems, where we will start right now after this shot here. Then the second section or the second level is about the different, more advanced systems where you use a lot of real components from the car and where you have a lot of practical tasks, workshop tasks, where you do directly diagnostic tasks on the system. The big advantage to the real car is that everything is absolutely student safe. So in other words, the training system cannot kill the student and the student cannot kill the training systems. That's especially when we are talking about high voltage cars, extremely important. And the last step then, so when we have prepared all the fundamentals, when we have prepared the workshop task and run through all that, then we go to the last step, which is something like here, in that case, the Audi Q5 Hybrid, our digital integrated trainings vehicle. So that means with this vehicle, we have, of course, a full function vehicle. It's like state of the art and it's a brand new car from the road, but we have modified it a little bit with some advanced systems so that you can connect it, for example, to a laptop or to a tablet and activate faults just by hovering through the e-learning course and just clicking on a page, and you can get different faults inside the car, do diagnostic tasks here. You have a lot of breakout boxes where you can do measurements on it. And so this would be the final step. And these 3 steps, again, they close then the chapter of Lucas-Nuelle Automotive. So from the scratch up to the expert level with Lucas-Nuelle or with our training systems over here. Right now, we will start with the fundamental systems, which is called the unit train systems. At the unit train systems, 1 or 2 people are working on it. And they are really there for that you can introduce the different automotive training topics, fundamentals, Canvas systems. So basically everything what is important to start with for automotive. And now we have a look at these kind of training systems. So we just have to move the scene. All right, so right now, you see here everywhere the different unit train systems. This is, of course, just a small part or a small choose out of the different unit train training systems. We start here from the right-hand side. We have, for example, a fundamental system for Canvas. What is special about these systems? So you see, if you want to explain something like bus system on the real car, this is really, really difficult because as we see the back car in the background, the big car in the background, you can't really see this bus systems in this network architecture because it's hidden inside the vehicle. What we have done here, we have just brought it out. So we have took the CAN bus from a real car and put it on these two cards so that the student can focus just this topic now of CAN bus system inside automotive. So we forget about all the rest of the car and just focusing that topic. And the big benefit here is that we have a real CAN bus running in this training system. The big benefit for this is we cannot only use the CAN bus in this system here, we can also connect real systems like the door. And just give me 1 minute, I will connect that here, that you see how everything is working together. So we have special instruments for that, where we can connect everything. So then I just grab the cables. And now we have connected it. I think, Dela, the door is, you will see the door? Perfectly. And now you see, because here we have a real CAN bus system and here a real CAN bus system is working, we can connect everything with each other and control it. So we can control the real door here from a production car through the CAN bus system over here. Everything works together. Window, the windows, central locking. And everything can be controlled just over the buttons over here. Through every kind of training systems, we have a so-called LabSoft course, which we will see later in more detail. So that means to all of the training systems, we have here an e-learning course on the computer running. So that means each single training system has its own LabSoft course, an e-learning curriculum. And the big benefit about this is it doesn't matter at which topic you are, even if you switch from automotive to another topic, you always work with the so-called learning environment LabSoft. So LabSoft is the frame where the e-learning course is running in, and all the content and all the different topics are inside LabSoft. That means if you have once understood, or if the students have once understood how to use LabSoft, they are able to use any training system from Lucas-Nuelle without any preparation time, because the handling of the software is always the same, just the content is changing. And even more, the big benefit here is you can use external measurement tools, but you don't have to, because everything is integrated into LabSoft. That means you have the so-called virtual instruments, which are fully functional voltmeter, ampere meter, oscilloscope. We have here more or less a 4-channel oscilloscope, and this is directly running into the software. So you have all the functions of a real measuring tool, with a big benefit that you don't need any storage place for it, because it's just digital and integrated into the Unitrain over here. So beside CAN bus, we have a lot of other Unitrain systems, even more advanced ones. What we see here is a brand new system. That's the Unitrain Lane Assist. That means here you can absolutely control and understand how the advanced driver assistance system, active lane assist, works. So this is the assistance system which keep you on track or keep you in the correct lane. And how this works and what can go wrong there, it's all explained in the Unitrain system. And we have a lot more ADAS systems beside this. So this is the latest development. On the left hand here, we see another advanced driver assistance system. It's the so-called Lidar system. So it's more or less a radar system, but which doesn't work with radio frequency, but with light. So it's a laser-based system. So this is also working together, or it's counting to the topic of ADAS system. We have parking assistance, we have traffic sign recognition. Della, just if you have a quick look over there, this is what you see over there. You see the traffic sign and all the different systems there. So these are even more advanced systems. And at least we have also so-called ACC, adaptive cruise control. You can come back to me. So that's right now not here, but I'm just giving you a general overview what is there. So in all the systems, for example, what makes them so unique? I mean, when we are speaking of ADAS system, ADAS is a really important topic for modern vehicle, and they are basically, beside the hybrid and electric vehicle technology, the ADAS system are the most important new development, and they are unique and absolutely necessary to realize the idea of autonomous driving car. Therefore, we put a lot of focus on this ADAS system. What is really important about ADAS inside the workshop? So what do the students need to learn? They have to learn how to calibrate this kind of system. So they don't have to really understand how everything is working in detail inside the system. The most important thing is that they know how to calibrate the system inside the car, that the angle in both directions is correct, and that the advanced driver system works correctly and have a correct angle on the street, that it detects the correct arrangement, basically. How is this done? This is done through different calibration devices. And the big benefit here, we can of course do the calibration or that at the real car, for example at the Audi here, but we need a lot of space and we have to invest a lot of money, because beside the car, which all needs the camera, the radar, and all these kind of tools, it's also absolutely important that you have this calibration system running. This is also over there. It's a very big one, so you really, you can't do it with more than 2 persons, basically. So it's a task for maybe 1 or 2 persons, but you need a lot of space. What we have done here, we have minimized everything and realize a calibration that you can bring on the table inside the classroom. So with each driver assistance system, it doesn't matter if it's now the Lidar system, the active lane assist, or another camera-based assist, or a radar-based assistance system. For each training system, you can do the calibration, or each student can do the calibration on its own inside the training center on the table. And this is a big benefit, because this ADAS system, or the calibration of the ADAS system, is the most important thing what you have to do when you have to touch ADAS system inside the workshop. Beside this ADAS system, there are a lot more unit train systems. So we have fundamental system, which are just doing the fundamentals of electronics and electrics. How do I measure voltage? How do I measure current? What is a series connection? What is a parallel connection? What can I do with Ohm's law? So all these things, this fundamental knowledge is also available inside the unit train course. And the unit train course is built up from these very fundamental topics, like I said, up to the more advanced topics, but it explains always the fundamental knowledge of it before you jump from these topics then to the more advanced topics on the other systems. An example for these more advanced systems is, for example, our modular engine management system, what you see over here. So, like we said before, when you have understood the fundamentals of electronics, electrics, the fundamentals of an engine management system, so what you can learn by unit train, and you want to have the more advanced stuff, then you jump to the second stage, which is, for example, here, the modular version, or if we have a look over here, it's more or less the same in a compact version. Big difference is, here everything is already connected. You can just start it by flicking the switch. About the engine, sorry, that was the wrong button. So there you see, you just started over the ignition switch and the whole system is running. You can accelerate it, and all the sensors and actors are working together. We'll have later look at that. Pretty much the same you will find over here, but here the student has more to work with the circuit diagram, so which is printed out over here. You see here on the table, that's, for example, the circuit diagram of this training system. So here the students see how he has to connect the control unit with all the different components over here on the system in order to make the function available. Big advantage here is for the modular system, you can just change some modules and reprogram the control unit, and you can switch from a petrol engine, for example, to a diesel engine. Or you can jump from an older petrol engine to a modern gasoline direct injection. What we have here now is exactly a modern gasoline direct injection. And like I said before, everything is running. We have our 12-volt battery. We have the control unit with the ignition switch. And when nothing is changed, we can directly start it here as well. You see, I flick the switch. Now the engine is running. We have the camshaft sensor. We have the crankshaft sensor. We have the camshaft sensor over here. The system is running. Different more sensors like NOx sensor, mass airflow sensor, oxygen sensor, and even air pressure sensor. And the good thing about this is now on each module you can recognize a potentiometer and a switch. What does it mean? We have at the switch real and simulation. So that means you can switch between the simulation of the sensor and the real working sensor. So for example, when we choose the mass airflow sensor over here, you see right now it's put to simulation, and I can now control the amount of air which is simulated going through the air sensor just by moving the potentiometer. And I hope you can see that on the camera. Do we see the LEDs, Dela? Yes. Okay, now you see there's an injection because there's an amount of air going into the engine. So the control unit calculates the right amount of fuel which is added to the air. When I now go to 0 with the air, we see the system doesn't recognize any air anymore. So that means now there's no fuel added. So there you see that everything is interacting with each other. Now I go back to the middle position and you see the injection starts again. When I switch now to real mode, you see, of course, there's no injection anymore. Why is that so? Because when you have a look now at the mass airflow sensor, there is no airstream going through it. But now we can do the following thing. So I will now simulate the airstream and just putting air through it. And Della is just filming the LEDs here. And now when I do that, were they on for a short time? There you see, you can activate it just by using the real sensor. And this not only counts for the mass airflow sensor, that's for all the different sensors. It could be the NOx sensor, where you could knock on then with the pressure sensor, of course. And even here, of course, we have the gas pedal sensor here. So when we move that, we can accelerate the whole system and you see how it speeds up. And even the control valve is opening. We have a real ignition spark. So everything is working like in a real system. But the good thing is everything is short circuit proof. So even if someone is doing a short circuit on the different modules and system, everything will work fine. And no one can destroy the control unit or the different sensors and actuators just by short circuit it. Okay, furthermore, what else do we have here? We have here a complete measuring tool also integrated. That means, of course, you can use external measurement tools, but even here we have our measurement tool where we can directly do different measurements. And how this looks like now, we will switch here to the course. Oh, shit. So I just share the screen. So I hope you see it now. Okay, one moment. Yeah. I just had to restart laptop. Okay, so now you should see it perfectly. Right now we see the LabSoft system over here. And because this is now a brand new system, I will show you something inside the German course. But here you see also that would be now all the English courses for it, basically. So this is LabSoft as we see it here. We have here the instruments, oscilloscope, for example, voltmeter E, voltmeter B, where we can directly start and do measurement, for example. So right now we are connected to the crankshaft sensor. So that will mean I will jump into the section of the crankshaft sensor. This is that we go sensors, crankshaft sensors. We have different animations here, for example. So it explains now where you find the crankshaft sensor. We have remodeled a complete 3D engine for it so that we can take different animations and videos out of this 3D model. Here it shows what it should look like now, or for what the sensor is used, basically to measure the RPM. And on the next page, then we see how the signal looks like for it. So that means when we look here, we have now the engine speed on the one side, but on the other side, we see...
Can you please switch off the engine? It's very noisy in the background. Thank you.
So we see here now how the signal looks like, but I just have to activate it soon again when we do the measurement, because now here, for example, we see now the different animation, how everything works. We switch over to the electric circuit diagram symbol. So there, before we do the measurement, we see how does the sensor looks like in the circuit diagram. And we can here click on the different connection in order to get to know what it is about. Then we answer some questions. In this video, then we directly see how it's connected to the control unit. On the one side, on the circuit diagram level, on the other side, in the real world. So there's everything connected. And then we can jump over to the experiments. So that means we have now the first experiment here where it's about, we get a workshop order here, which shows how to measure the crankshaft sensor. So the workshop order says basically, please check the crankshaft sensor. This is exactly what we do. So then we jump into the car and just see what we have to connect here. So that means that's our fundamental setup. And now we connect the measuring tool to the hardware, which we have done here already. So in the next page, we need the oscilloscope. We have to prepare it with the informations over here. So 5 milliseconds, 10 volt. We do a trigger on channel A. Put it a little bit at the front. And now we just start the system. I have to reduce the trigger a little bit. And there we see now, there we get now exactly the signal which we have seen before in the animation. And of course, nothing is simulated here. When we now accelerate the system, we see directly how the things or how the signal is changing. What we can do now, it's like we don't have to keep everything in mind. We can now copy the picture into the clipboard and then just paste it in here. And then we can shut down the engine again and see directly how the results are saved inside the student's account of the LabSoft. And I can now close the program and open it again, and all the students' results will stay in here. So that means we can always, get in feedback and check the values and the results of the student. There are further questions, and at least he can fill out a final protocol in order to give even more detailed overview about his measurement. At the last step, I also want to show a little bit more animations of the system that you really see how much time we have invested into that system. Because we all know that students are not too keen on reading. So what we have done here, we really put the focus on that we do less text and a lot of videos and animations. This now is, for example, a chapter about the fuel pump. And even if everything is in German, it doesn't matter, because just through the videos and the animations, we see what happens here and what the single pages want to tell us. So the first thing is the positioning of the fuel pump. We directly see where we find it at the back of the car under the rear seats. Okay, what's the task of the fuel pump? That means we have now more or less jumped into the tank and see a cutting model of the fuel pump. We see here a measuring tool for pressure, and we have here some, basically our speed, our engine speed, temperature, and the start button. When we start now the animation, we see at first just the ignition is activated, so we don't have the engine running. And the fuel pump is running for around about 10 seconds in order to fill up all the fuel lines. When there's no speed signal is coming, then it will deactivate it again. But as soon as we start the engine, then we see the fuel pump is running, and it's working with 5 bar right now, and then it's dropping back to 4 bar, and temperature is increasing. Okay, when we jump back to the next animation, there we see now, even like before, not only the bar value, the pressure value, but also the signal for it. And we see it's a PWM here, and we see how it's changing or affecting the pressure value. It's getting thinner, and then the pressure will decrease. When it would get bigger or brighter, it will increase the pressure. Then we show as well, okay, what happens when we are driving around corners and we don't have such a high fuel level. We see, because the catch tank is always filled, we now will get problems that the fuel pump doesn't get enough fuel. And in the last step, we see always here how the fuel sensor works. And that's now even a very nice thing, so I just have to connect something. From this page, now we jump directly in the first experiment, where we see now like the cockpit of the car. And when we now switch to another measurement, basically, which they explain right here. So we see here the fuel pump, which we have seen before, inside the animations. Is directly the fuel pump which we see here. We have here more or less what we've seen in the animation before, the level sensor for the fuel level. So it depends where it is. We see a different fuel amount of, or we have a different amount of fuel. So now I just connect this up to here and this up to here. And now basically we are measuring now this fuel level sensor here. And what you see now, sorry, just have to. So now we just have a lag in the animation here, but basically then we see how the fuel level sensor is going up again. Sorry, ignition was failing. There you see it right now. So that means I'm now controlling, we see both, right? I'm now going up with the sensor over here, and we see directly in the animation how the fuel level is decreasing or increasing depending on where I move this sensor. So there we see we have a direct interaction between the hardware and the software. Everything is working together, and it's really an interactive training system where everything works together. For the final step then, when you have worked through all the different experiments, Then you have even practical tasks. So that means when we jump in here, we have like a PDF which we can open. I hope Microsoft letting us do that. Here we go. They always change that. So there is we're getting a PDF basically where we can open then a worksheet which we can print out, and this worksheet is generic. That means we can use it for any type of car. So basically when we have run through the chapter of fuel pump, then we can print out the task sheets and run over to the car, which we doesn't have to be an Audi, it can be any car you just have at the place, and there you can do different experiments then on the fuel pump. There is a circle closing between the training systems and the real car. Okay, and when you have run through all the different chapters, then you can be pretty sure that the students have a very good knowledge about the certain system of a diesel engine, or in that case now of a gasoline direct injection engine. Okay, were there questions so far, Della? Have you seen anything? You just checked that, okay.
Christian, maybe you can just show also some English content, not that the clients now think that it comes just
I just have shown the latest course, and this is just in translation, but of course we have here then for the direct fuel injection. So this is without this modern fuel pump, this is the older fuel pump, but there you see then the same chapter basically in English. Okay, so there all the questions, everything is in English or in the language of your country then, which you like to have, where it gets translated to then.
And basically, we have already in Labsoft that you can show how easily you can switch out to the basic courses, for example, for basic of automotive sensors and so on.
I can't do that here because we have here a network installation, and here's everything just focused on the system which we have right here. So I know what you mean. So basically, you would see now every course which you have installed, you would see in this table of content, but in this trainings room here, because there we have to install all the different courses which we have, which are 100. So that would be the too long list. So what we have done here, we have created a network user for each computer and just show the content in a different language, which you see here in hardware. So, but basically, when you have now different courses, you would see everything in a row, and you can just switch from one course to the another. Or what I do here, we have here common rail, for example, for diesel, and I can just shut that and switch here to gasoline direct injection. Or same in English, of course, as well. We have here system common rail, direct fuel injection, Motronic 2.8.2, and we can just switch within seconds between each of these different systems. Okay, Sebastian?
Yes, perfect. Thank you very much.
Okay. Coming from that system, like I said before, the benefit of that system is that you can just, if you changing some modules, you can changing from one system to another. So like I said, for example, from a diesel to a gasoline direct injection. When we have a look now at these compact systems, sorry, I have to stop sharing. We have basically the same idea, but like I said before, everything's already connected. We see here at this area, we have also the simulation and the real function of the different sensors. We have engine speed, we have engine temperature, air temperature, NOx signal, we have mass airflow, and we have the lambda value of a new oxygen sensor or of an older oxygen sensor. There you see another kind of like a slower regulation. Everything is connected, so we don't have to connect the control unit up here. What you see here at the bottom is also the control unit, but here they are just measuring points. And the big benefit of this system is now that you have a complete fault simulation into it. So that means you also work with the circuit diagram, but here now we can just by clicking on the fault section or fault chapter inside the course. So we have here, let me have a quick look. we have here above 20 different faults, which we can activate just by going on the page in the system. So that means, for example, we can have a faulty crankshaft sensor, we can have a faulty camshaft sensor, we can have a not working throttle valve anymore, or a not working mass airflow sensor. All of that we can activate just by clicking on one page. Then a relay is activated inside the system. Fault is there. Some faults can also be read out by an OBD code reader. And then the students can do the measurement, write down inside the course what their findings are. So what they have, how have they measured, and what they have find out, what is the problem. And they can save this in the course, and later on you can talk about if this was a good strategy, how they run through the problem, or if they have lost time, or maybe they've even not found the right problem. As soon as you leave the page, fault is deactivated and the system is running in perfect shape, or like a brand new system again. Besides this Motronic 2.8, we have also a common rail diesel system, and we have a gasoline direct injection system. Beside these car trains, so we have to see with the camera now, we have some car trains which do a closer look at the different sensors. So this system here, for example, now is not showing now a complete engine management system, but is showing the most important sensors and actors out of an engine management system. So we have different pressure sensors from different versions, different cars. Pressure sensor, a boost pressure sensor, another boost pressure sensor. This is like a differential pressure sensor, which is used at the, what's that in English? It's used at the particle filter. At the, for example, at the diesel particle filter, there you see when you have the pressure in front of is higher than at the back, and this is getting over a certain differential value. That means then the filter is just, done. It's full and you need to clean it. And this is done by this sensor. And on the very right side here, we have an air quality sensor. This is mounted close to the window, or to the front window of the car, where air is sucked into the driver cabin. There you see, for example, okay, is there good air quality, or do we have some bad emissions into the air? And that means, or this sensor is used for this automatic regulation when you want to get fresh air from the outside or keep the air inside the car. And that means, for example, if you drive into a tunnel where there is a traffic jam and you have activated the automatic system, that means it will shut down or will close the claps and let the air stay in the car and not sucking new air into it with the bad emissions. Furthermore, we have then e.g. air valve, a unit which is this comes from the earlier gasoline direct injection systems, which are so-called the FSI, fuel stratifier injection, where you can control the tumble claps with. And we have a fully functional throttle body. And down here beside this gas pedal, we have two different mass airflow sensors. So one conventional and one which is using a bus system, more or less, or not a real bus system, but there is, it's not just a DC voltage. Here we have like an AC signal. In this AC signal, it looks like a PWM. There are different informations like air temperature, mass airflow, and some different values even more. There you see the different kind of wiring. So we just have 3 wires over here. And at the classical one, we have 5 wires. So there enough, we save money we save money through having less material used here and to have less weight, basically, which is for the car manufacturers pretty important. Down here, we have other temperature sensors, NOx sensors, and of course, our measuring tool is integrated in here as well. And the good thing about this, so in the latest version of the measuring tool, you can connect this measuring tool via Wi-Fi. So you can use a USB cable, but you don't have to use a USB cable. That means if you have a tablet, you can just connect by Wi-Fi with this unit and do the measurement then without any cable on the tablet. Again, here's as well, of course, e-learning course coming with it, which is explaining what you can do here and which is explaining all the different experiments. And here are also a lot of diagnostic tasks in it. I think we have more than, don't let me lie. Yeah, we have here more than 47 job orders into it. So the students have a lot of diagnostic work to do here. And each page is reflecting a problem with a sensor or with the actor. So if you have run through that, then you really know how the sensors work or the actors work and what can happen to them. Perfect. You were just over there. Exactly. Were some questions? No. So we change now the place. And now we are here. So more or less we have read now in a circle. At the back, you see the other car train. So like I said, this is what I've explained before, but this is the gasoline direct injection. So that works completely the same like the Motronic, but is focusing the topic of the gasoline direct injection here. Therefore, we have the different injection valves and all that. On the left-hand side there, you see this is a car train, which is a little bit beside engine management. This is focusing ABS, RSR, braking system. So the electronic brake systems, basically. You have a real brake system running here. So with real brake fluid, with the real brake booster and everything, you can activate it. And then the whole system is working completely mechanical, basically. But you have the wheel speed sensors there as well. You have fault simulation into it. And what you can do with it, you can run the complete system of ABS, which is a very nice thing. Because to see ABS working in the real car, you need to drive on the road and you need to have a critical situation there. But on the other hand, you also cannot really see it, what's happening there, because everything is hidden in the car. With this system here, you directly see where the pressures are, how the pressures are generated, and how ABS is working, basically. Okay, and at the last step, to finish engine management section, Della has to move the camera a little bit. We have here a very nice mechanical model. So this is now non-electronic or electric, but it supports the car trains very well. Like we have here. When we have here explaining how the sensors or what sensors we have, what actors we have, and how they're working on an electrical or electronical level with each other, we see now here the complete setup. I think you have to zoom in a little bit. We have the complete setup of a modern gasoline direct injection engine. What is the big benefit about this one is here? We don't have like a cutting model, so where everything is like normal and just one part is cutted away and is missing. Here, even if you move a little bit down, you see that we have a complete explosion view of the whole engine. Nothing, no component is missing. We have the turbocharger over here. We have all the injection valves are placed here. We have the different things for regulating the camshaft or the sensors and actors for the camshaft regulation. What we see here, we have the single spark ignition coil. We have all the gaskets over here. And we have also a combined, the throttle valve is behind here, high pressure fuel pump. And we have here the complete, the complete part for the complete air pipeline, basically, where the air goes in. And where the air is cooled, the compressed air is cooled down and then running into the different combustion chambers. So, like I said, a perfect match with the car trains together, because here everything electrical is explained, and here you see then how everything is put in place on a real engine. And both together are just working perfectly together. Okay, coming now from this classical engine management to our very modern systems, what we called our high voltage section. And just Della is moving a little bit back that you get a complete view of it, which is basically right now here. So even when you go a little bit down, that you see our barrier here, our safety zone. Exactly. So that means we take it really seriously, this whole topic. And it's not just about the technique itself. We put a lot of focus on the aspects of safe working. So that means this starts, for example, that the students have the task in order to create a safety zone around their working space. So if they are working on a high voltage system, that they directly know from the beginning, okay, how can I create a safe workspace? And I do that if I start with creating this zone all around my car, or in that case, all around the car trains. What is the biggest benefit or the most important point about these car trains? So it doesn't matter which car train we're focusing here. So what do we have here? We have here a car train for the high voltage battery. So that means this car train is the advanced step then. This is when you know about the fundamentals of hybrid electric vehicles and how to work safely around it. This car train takes you even more into the topic and enables you to work inside a high voltage battery. So we have a real high voltage system here. This is a real high voltage battery, a lithium ion accus, and you learn how to deal safely with this high voltage battery. How you can completely dismount it and working into it. But closer look, we will have later on that system. But like I said, it doesn't matter if we're focusing that system or this system here, our hybrid electric vehicle trainer. This is our biggest success, you can basically say, because it's used all around over the world for the different skills contests or events. So we have the Euro skills, we have the world skills, and we have started with that systems in the skills USA. So that means, the skills events where basically they say, we want to find out who's the best automotive student in different areas. And they have of course, all the classical areas covered, like engine management, electrical fundamentals, working on combustion engines. But it was like, okay, the hybrid electric vehicles are so important and they're getting more and more on the road. And we have somehow really to focus on that inside the different skill contests all around the world. Because when we want to have the best automotive student, maybe next time out of your country, they also need to know about, and they must be safe working on hybrid electric vehicles and on high voltage systems. And this is exactly what they have done at Skills USA. And that was the first time my colleague Daniel and we were visiting the US for that. And they used this trainer instead of a real car, because a real car needs too much space and it's too dangerous to let someone work on who has no idea about it and not the right qualification. So they started to work on that system, and they have to complete the main task on it to shut down the high voltage system before you can do any diagnostic or repair on a high voltage car. Very, very important. Perfectly done by this system. And also this system has a real high voltage system. If we do a measurement at the inverter, there we see that we have a voltage above 300 volt. And same with this system over here on my right hand side. This is more or less the big brother of the system before. This is now focusing the same main topic, but this is now not for passenger cars, but for commercial vehicles. So that means we are focusing with this high voltage trainer, all the trucks, buses, and all the electric heavy duty vehicles which are on the road. Short information as well. So even the high voltage battery trainer has the same big brother, where you have a version which is focused on trucks. So you don't have a car then here, you have a truck, and all the content is focusing then the heavy duty vehicles. Okay, perfectly. We will have now a closer look at our high voltage trainer over here. So like I said, we don't refer too much to this truck train because it's basically exactly the same, but I will show it you over here because here we have the full translation. Before we go into detail here, at the beginning I said that we are working closely together with the IMI, the Institute of Motor Industry. This is a body from the UK, which, their goal was at first in the UK, but now even worldwide on an international level, to create a curriculum and a qualification that everyone all over the world can train high voltage experts. They have a curriculum for all over the automotive area for the complete light vehicles, heavy duty vehicles. But the unique thing what Lucas-Nuelle and IMI has realized right now and what we can offer to you right now is a project or is a bundle, a program where we show or where we have connected the high voltage, so hybrid electric vehicle training with our training system and connected this with a qualification. So that means together with these training systems, you can run through different qualifications or your students can earn different levels of qualifications. And there, of course, we can send you even more information for more details. But just to start with, we have 4 different levels here. It starts with a very fundamental level, which is created for test drivers, cleaning stuff, or all that, just people who can get in touch with a high voltage car. So they don't repair it, they don't open any systems there, but they need to know that when there are orange cables, for example, don't touch it, and they just need to, you have to create the correct awareness of it for these people. So this system or this qualification, you get a real qualification for it. It has its own course and it comes together with our training hardware basically together. So this is what you call EV1. Then you have the second level, EV2. And EV2 has 2 different levels. EV 2.1, which is focusing, very important, the first responder. So it's not only about the guys who are in the workshop and who are repairing or designing these cars at the car manufacturer or repairing it in the workshop. We have also to think about to train and qualify the firefighters, the police officers, so all the first responders who can get in touch with a hybrid electric vehicle in case of an accident. So it's not the guy in the workshop who has the first or who has at first his hands on a damaged vehicle. It's in most cases that are the firefighters, especially if they have to rescue a person out of the car. And for that, together with the hardware again, we have our own e-learning course, which is just focusing this qualification. So there is our own e-learning course for that you can complete the qualification for these first responders. And then we have 2 different levels or 2 other levels, which are focusing the guys in the workshop. So 2.2 and 3 will be focusing the repair of or the diagnostic on hybrid electric vehicles outside the high voltage battery, which is very important. But this is like, you learn how to shut down safely a system and you learn how to do any diagnosis on the car outside the high voltage battery. And then we have the last qualification step, which is EV4. And EV4, when you have this one, then you are really on the top. Then you have the highest qualification and you can call yourself a real expert for hybrid electric vehicles. With this EV4 qualification, you are able to work inside the high voltage battery. So that means you are able to work under high voltage. You don't have to shut it down before. And it enables you also to work on a damaged hybrid electric vehicle, because there you can't say that the safety systems still work and you have to assume that you cannot shut down high voltage. And therefore, this EV4 qualification is so important for the workshop that you can, on the one side, open the high voltage battery, but that you also can, on the other hand, that you can work on a damaged vehicle which comes into the workshop, and you have then the right qualification in order to understand if this car is creating a big danger or not. So, for example, if you have a damaged high voltage battery, you can't store it inside the workshop. You have to put it somewhere outside in a special area where it can touch nothing else. So where are no trees, where are no other cars, no human beings or other buildings, which could catch fire if the high voltage battery catches fire again. So these are the 4 different levels. And with our qualification program, together with the IMI, you can get a qualified IMI training center, and then you can, or this can enable you then to teach all the 4 qualification at your training center, just together with our training hardware. So that means your training center can become and state-of-the-art training center for your country where you can train your hybrid electric or your high voltage experts in your country then and make them available for the market. Let's now have a closer look at first at our hybrid electric vehicle trainer. So like I said before, what you see here, we have a complete high voltage system here, but everything is completely student safe. So even if we have 300 volts over here and we will stick in with something metal, nothing will happen to the student because the energy, so the amperage which is running in the system, is kept so low that nothing can happen. At first, we get a quick overview about what we have on the systems. So we started here already with our high voltage system in the case of a block diagram. That means here we have the unique chance to measure inside the high voltage system. So we could measure inside the motor generators, inside the inverter, or even inside the high voltage battery. Are you able to do that on a real car? No, you are not able to do that because that would mean you have to open and manipulate the high voltage system, and that would be really, really dangerous because you can't say how the car reacts. In the best case, the car just shuts down and you can't do anything on it. In the worst case, the car can catch fire, for example, when you're creating a short circuit or something like that. Even more, or even a more harder quality challenge is not only the measuring, but also if you want to do some diagnostic task on it. That means if you want to put faults on the car. So what do we have here? We have here our own simulator with, there are more, but we have 7 different faults which you can bring into the high voltage system. So we see we have here a fault for the electric motor, for the high voltage battery, for the inverter, insulation fault, and 3 faults which are for the potential equalization or for shielding problems. So basically, of course, more faults can occur inside the high voltage car, but these faults, especially the insulation fault, are the main faults which can happen or which are happen on the road. So we have talked to the car manufacturers during the development process and to different workshops, and we just got the feedback that these faults are the faults which are mainly occur on a hybrid electric vehicle on the road. What is the big benefit here? Of course, you can imagine if you want to put faults inside the real car, you can get massive problems here because now you're not only putting measuring points to the high voltage system, you really have to put faults into a real high voltage system. Like I said before, this system is designed for training. A real car is not designed for training. That means they are running hundreds of ampere through it. And if you do there a short circuit or you just destroy something by manipulating the high voltage system, this could be really, really serious. Here, you are absolutely easygoing. You can just activate the fault by flicking the switch. And if you don't want to or you do not need it anymore, you just deactivate the switch again, put it back to 0, delete the fault codes, and then you are good again. And you don't have to fear that you have destroyed anything or that there could be any danger or risk for the student. This system, like I said before, is completely student safe. So moving now from this upper area to the lower area. Another problem which we have, of course, we don't have just one type of hybrid or electric car on the road. There are different types, especially for the hybrids. So if you want to understand from the technical side how the different hybrid systems are working, or how the different hybrid and electric systems are working, you would need around about 5 different cars. So except the space, this is also a point about money. Here you have 5 systems or 5 cars integrated in one training systems. We can start with the series hybrid, for example. So the series hybrid is nothing less like an electric car, for example, with the range extender. Good example for that is the BMW i3. Next step, parallel hybrid. The parallel hybrid, BMW used this as well pretty often. It's like where you add the high voltage system parallel to the combustion engine. You see it in here. So the electric motor is in row or in series with the combustion engine. Then we have the series parallel hybrid, which is kind of a mixture out of the both systems from before. Pretty common example for that is the Toyota Prius. And then we have the pure electric vehicle, very easy setup. And don't forget, a lot of people are speaking about it right now. Again, it's the fuel cell vehicle. So with this one trainer, you have the 5 most important, or basically the 5 existing systems inside, which are on the road right now, or which are used inside the cars, you have in one training system. And how you can operate it, pretty easy. What we see here, for example, we can go to the touchscreen mode, and now we see our surface of the series parallel car. So this is just like the car without the chassis, where we can look underneath it. How can we switch now, for example, to the pure electric vehicle? So therefore, we have another overlay mask. And what we have to do now, we just need a few seconds for it. We disconnect the measuring leads. We shut down the system in the best case. Disconnect the bridge connectors and this bridge connector. And now we can remove this overlay mask. Just switch to that overlay mask. Connect the things again. And here. And when we now start the system again, we are now switched from the series parallel drive to the pure electric drive. There you see. And it just took us less than 1 minute. And same with all the other systems. You have, for any system, you have the different overlay mask and can switch within seconds from one system to another. So, but when we have now the car over here, what do we see? We are already in ready mode. So that's pretty important, because here we see that's the most important term for the driver, because when there's no ready mode, the car is not able to drive. So I do it again. Now the ignition is deactivated. Ignition is activated. You can stay up there where you were before, Dela. So now we are in the standby mode. And when I now start the car, we go on preload. And finally to ready. So that means now the car is into operation and the high voltage system is working. So we just click here now on the chassis, and now we can accelerate the car. And what we can do now is basically see the different energy streams inside the car. From the high voltage battery, so for electric drive, it's pretty simple. We have the electrical, so the electric energy moving from the high voltage battery over the inverter into the electric motor. Or when we are driving downhill, we see now the opposite side. Now we don't have to create drive moment because we are rolling down the hill. We can do the recuperation. And that means now that are symbolizing the green arrows, we are now getting electrical energy back through the inverter into the high voltage battery and can charge up the high voltage battery. These different energy streams you can show, of course, for all the different type of vehicles, just by switching the speed, the type of road where you are driving, downhill, flat terrain, or uphill. And you can even over here, you can choose the state of charge which you want to use. So that means you can simulate a complete drawn high voltage battery when I move it to the left side, or you can simulate a complete fully charged high voltage battery. And you see basically everything right here in that window. So it says now 99%. Or even when we go back, same inside here. So everything is there. What else is important about this touchscreen? What you see down here, we have our OBD connection. So why it's important to have this OBD connection, but why it's a digital one? The problem about, so on the one hand, we need an OBD connection in order to read out the fault codes. This is pretty important because basically you cannot look inside the high voltage system. So the car manufacturers created a very smart onboard diagnostic system which monitors the high voltage system very well and which will give you detailed information if there's any kind of malfunction or problem. But the problem is that normally, in order to really dive deep into the high voltage system from diagnostic side, you need the tester or the diagnostic tool from the car manufacturer. So the free tools on the market from third parties, it's pretty difficult with them really to have a deep dive into the high voltage system. This is why we have created our own digital one where we just click in. So, and then we are inside our diagnostic tool. Right now, I hope when you go a little bit closer, you see, yeah, there are no faults present. For example, what we can do now, I just activate a fault. Sorry, I jumped into it. So now I've activated the fault, and now we see original P code P3009, high voltage leak to ground. Okay, that means we have now a problem with the insulation. We can even go to actual values, have a check there if everything is okay. So we see different values here. We see the status of the relays, of the active discharge function, many different informations. But right now, we still have the problem, like I said before, that we have a high voltage leak to ground. So somewhere the insulation is faulty. Now we have to find out where this is. So what we are doing for that is we shut down the whole high voltage system. So what does it mean? We do now exactly the same what we would do on a real car. So that means we start with, and like I said, we will have a look later at the course, or I will share it in a moment. And everything what I tell you now is also explained in this e-learning course. The e-learning course has right about learning content up to 100 hours. So we have put everything, a lot of effort on this e-learning course, that you have the whole topic of hybrid electric vehicles for the fundamental section in that e-learning course. And our goal was, and this is what we have reached, that you don't need any external sources. So you have the fundamental section in the course, you have hybrid supporting systems in the course, so classical systems like the combustion engine, air conditioning systems, what is different on them when you have a high voltage system. And of course, you have the whole bunch of hybrid electric vehicle topics in that course. And this course is completely aligned on the one hand to the curriculum of the US, but also, of course, like I said before, to the IMI curriculum and to the German curriculum. So with this course, you can really fulfill all the different curriculums all over the world. So right now, I just share that screen that you can see it here. So perfect. So that's the course now. I just jumped to the page where we do the shutdown. Give me a second, please, because we're here on the Wi-Fi. It has to charge a little. It has to load the pages a little bit longer.
Chris, maybe tell them that they can make the screen side by side and they can increase or decrease the size of.
Exactly. There you, like Della said before, you have like a bar at the middle there where you can increase the. If you want to see myself a little bit more, you can put it to my side so I get bigger. If you want to see the screen a little bit more, just adjust it to the side of the screen. There you see then the shared screen a little bit bigger. So, and we just jump, for example, here inside the high voltage disconnect procedure. And just to give you an idea how this is now carried out, we're just running through that chapter. And also in this course, we have used a lot of effort in order to show you things which are important to know, but which you cannot perform on your own on a real high voltage car because it's just too dangerous. And what I mean is, while we jump to that page, sorry, it's a little bit slow today, but that's due to technical issues in the internet connection here. Or maybe because of a Windows update is missing. So we have all the topics like risks of working with hybrid and electric vehicles, where we really explain everything in detail. But I want to go to that page over here. So we have talked about electrical isolation, intrinsic safety of a car. And what is really important, what you see here now, for example, if you have a problem with the interlock or with the insulation, what can happen right now? So we have here a video which we have created together with the car manufacturers. And there you see now a high voltage cable, which is under load. So we have real high voltage running on, but the safety systems are deactivated. And what happens now when we are pulling that cable under load from its socket? And there you see right now everything is easy going, but soon we will see what happens there. And that's even reduced energy, electrical energy. So that's not like, there you see it. So it's like an explosion. And even here, the amount of electrical energy is reduced compared to a real vehicle. So this is something like what you really want to show the student, what can happen, why it's so important that all these intrinsic safety systems are working, but you don't want to do them that experiment in the field with their own hands. Therefore, it's great when you can use these kind of courses there or videos. So then we switch back because we just said, okay, we've seen now what can happen when something is really, really wrong, but we are jumping back now to the high voltage disconnect procedure. And also here, we are also trying to involve the real world and want to bring in the real cars. So before we shut down the system itself, we have, for example, an example inside the course which shows the shutdown of the Toyota Prius. If Windows, okay, I need to be a little bit slowed down to give Windows a bit more time in order to load the whole course. So thank you. So there we have, for example, a practical example for the disconnect procedure of the Toyota Prius 4. And this is very important that we can do, or that we can bring in the practical relevance always into the courses. Of course, we know that's the e-learning course, but we want to bring in as much practical information as possible. So, and here, for example, in this video, like I said, it's a little bit tricky today because of the internet connection which we are using here. Basically, when you install that local on your computer, you don't have any issues with your local intranet or anything like that. So basically this video, okay, I just see it now, the connection is too bad here, but this shows, for example, how we can disconnect a Toyota Prius 4 in real life. So how we do a real disconnection of the high voltage system of a Toyota Prius 4. But we will do it now on this system over here. So like I said, what we are seeing now, everything is explained on this page as well. First thing what we are doing is that we, of course, park the vehicle. We have read out the fault memory. Everything is okay. We know there's an insulation fault. And now we shut down the car. So we take out the key. And what are we doing now with the key? Very often, the people just put it into the pocket. This is a problem out of different reasons. Because on the one thing, the pocket is not the safest place for such a key. Why not? Because basically nowadays we have normally smart keys with the cars, and when we keep the car, or when we keep the smart key inside our pocket or somewhere close to the car, we can activate the high voltage system again. So what we have to make sure to keep the key far enough from the car. But will we put it just on the table? No, of course not. This is why it comes together with the system. We are using something like this lockbox. So this is official lockbox which you can open, and then you put the key into the lockbox. We don't have, I just put it to the side right now. We don't have to lock it right now, but later we have to guard it by a padlock in order that only myself can open it and no one else. That's pretty important because when someone else gets to the components, he can reactivate the voltage system while we are working on it. And this is what we definitely want to avoid here. So that means we have shut down the car. We have put the ignition key into a safe spot. if you have a push button here, like for engine start or high voltage system start, press it again and really to make sure that there's no key anymore, because we have had a situation into real workshops or in real cars that the customers or the car owners not only had their normal key, but they also had their spare key somewhere inside the car. So I remember a story of my friend Daniel, who's also listening to that here, that he was in a situation where a guy has more or less, I think it was roundabout, he has hidden three or two additional keys, smart keys inside the car. So they had more or less to search inside the whole car for the different keys in order that they cannot start the high voltage system anymore. So also this can happen. So definitely make sure after you have removed the key that you really cannot start the car anymore. So the next step then is that we have to, in that case especially, to deactivate the 12-volt system. So this is what we have down here. I hope you see it. Maybe you do a zoom onto that. We have here a fast disconnect for the negative terminal. And what we are doing now, we are now disconnecting the 12-volt terminal. So now we have our 12-volt battery disconnected, and the system is basically, so the 12-volt board network is shut down right now. We have the 12-volt system is not running anymore on the car. So what is the next step? The next step would be, in order to touch an orange component, which we see down here. This is the service disconnect, used by Audi and Toyota, for example. So, but before we are allowed to touch this, we need first our gloves. So that means there are special gloves right here, so we don't worry too much. Sorry?
Can you repeat, can you change the screens? We see mainly the laptop software, but a new screen is very small.
You can adjust that, Sebastian. That's what I said before. There's a slider where you can adjust that, where you can make the
we can't do that. It's, oh, there we go. If you click the button up in the top, Sebastian.
Okay, I got it, yeah.
Yeah.
Okay.
Yep. Can go to view options at the top of the screen, and you can click side by side.
Thank you very much.
Thanks, Daniel. Okay.
Okay, please go ahead. All good, thank you.
Perfect. Okay, great. So the next thing, what we said, we need now the gloves. And the gloves are also a very important part of the PPE, the personal protective equipment. And we have now here special ones, which have also a protective layer. So common in the US is, for example, beside the rubber gloves, that you also wear leather gloves above it, in order when you're working at the engine bay or somewhere else where obviously sharp corners could be, that you do not destroy the surface of the rubber gloves and then destroy the electrical insulation of it. Before we can use the gloves, we have to check different parameters, which are also explained inside the e-learning course. So on the one hand, it's the class. It must be class 0, which is printed on the glove. I just tried to show that. Can you catch the 0 there? Perfect. So, and then you have also to check it, of course, if there are any scratches in it or any holes into it. We have it very easy with this course because they are black from the inside. We would directly see if there would be any hole inside the glove. But nevertheless, because there could be really, really tiny ones, which also could affect the level of insulation, we have to test it by rolling it up. And then now we have to see if the air is really kept into the glove. So we listen to it or try if we feel that air is coming out, but we see they are pretty good. They are keeping the air. Same we do with the other one. Also perfect. So they are basically brand new. And this is also brand new is important because we have to check when they have been tested the last time. So a glass shouldn't be older than 6 months. So when you see that the test date is more than 6 months back in the year or back in the day, then you have to retest them and use other gloves for your task right now. So, but we have, it's good from the age, it's good from the class, it's class 0, we have no holes in it, so perfect. That means we can wear it right now. Normally I have to put, or would put, all the watches and everything else, especially when a woman is doing it, we put all that away, and then we can get the gloves. So like I said, in the US you would use now as well rubber gloves, leather gloves on it, but these are special ones which have this protective layer, and it's like that there are integrated leather gloves on it, so we don't need the leather gloves here right now. So right now I'm allowed to touch the high voltage service plug over here. So and what I do, it's like the real one from the real car, and now I can pull it out. And if we have a look at it, is it sharp? So there we see we have the 2 high voltage connections, which is basically interrupting the high voltage battery mechanically. And we have here the small connection, which is obviously not high voltage. This is the so-called interlock. And when we wouldn't have shut down the car and just pull out the plug while the high voltage system is running, we would get a very strong fault, which will tell us that the interlock has been interrupted on the service plug. And this is as soon as you interrupt this connection over here. Little side information. What is the problem? What's the benefit of the car train here? And what is the problem on the real car? There was a situation when you shut down a hybrid or electric vehicle, a real vehicle, too often after each other, it could shut down itself completely. So the background is that the car manufacturers say, okay, you are just maybe in a test, you want to do a test with your students, or you want that 5 or 6 students should shut it down. But depending on the car, it could happen that after the 4th student, that the car says, okay, here's something going wrong, you can't I won't let you activate the high voltage system again. The idea behind it is that the car manufacturers say, okay, when there's a reason that the high voltage system needs so often to be shut down, there must really be a serious problem, and this should be checked by official car dealer then of the car brand basically. So that means you would need to bring the car to the official car dealer, and only them with their special diagnostic testers can activate the system again. Can this happen to that training system over here? No, of course not. You can shut down it as often as you wish. You can shut down it 50 times in a row, and this will be no problem for the car train. Okay, now we have pulled the plug over here, and where do we put that? This is a safety relevant component, and of course that means we put this as well inside the lockbox. And now we have everything inside here, so we can close it, get for a moment rid of these ones. I can close it, take the lockout padlock, and now everything is secured and only myself can open it. And this key I can keep in my pocket, for example, or at my body, because this cannot start the car, and this should definitely stay in my hands and shouldn't get in the hands of anyone else. So because here's only Della and I trust her, I put the key over here. And now what do we have to do? Now we assume that the high voltage system is shut down because the ignition is shut down, the 12 voltage system is deactivated, and even the high voltage battery is interrupted. But we just assume it right now. That means now we need a proof through measurement that the high voltage is really gone. How are we doing that? With a measuring tool. Of course, we can use something like that here. This is our typical tool, what you use here in Europe. He called it the DUS pole. And it's basically pretty cool because, you just can connect these two tips here over, and then you see what kind of voltage is over there. So it goes from 12 volt up to 690. But before we go to the high voltage measuring point, we have first to test it. This is what we call the live measurement. So at first we go to a live voltage source, which is in that case a 12 volt battery. That I don't know if you can connect, get that. So there we see now that we have DC plus 12 volt. So, okay, we expect 12 volt here because it's a 12 volt battery. So this tells us that the system is working correctly. Always make sure that you use as a test voltage this voltage, which you also want to measure. So if you want to measure a DC voltage, the test voltage should also be DC. And before now I can open everything in here, I have take again the glass, and then I'm allowed to open the high voltage measuring point, because this is now where we can open the inverter cap over here. And you see, it's much fun with this glass, but it's important that the students are doing that too, because it's the same what they have to do on the real car. Therefore, it's important that they remove that with the gloves together. And also here we have an interlock. That would mean if you would open this cover under a live high voltage system, this would create again a very serious high voltage fault and tell you that the high voltage system is shut down, emergency shutdown, because the interlock has been interrupted. But there we see now our high voltage measuring points. And what we are doing now is that we do now the dead measurement. So we remember live, dead, live. We are now at the dead measurement because now we want to see that there's no high voltage anymore. So we put that together, and together with this, there's even another rule. It's called the one hand rule. So what I'm doing now, I'm getting one hand away in order to show you and just measure everything just with one hand. And now we see the system is not showing any voltage here. So why have I done it with one hand? Because it looks cool? No, because I don't want to create a circuit over my body. In a worst case, what can happen when I would do it in this way? I would have a circuit over my arms, and this would affect my body. If I just have it in one hand, there's no chance that the current is, or a much smaller chance that the current is running through my body. Now we have seen, okay, there's no voltage anymore, but to be really sure now that we don't have destroyed the measuring tool while we have done the measurement, what are we doing right now? You remember live, dead, live. We're going back again to the live measurement. And there we see still 12 volt. Okay, the system is still working. Now we can assume that the high voltage system is shut down and that the high voltage system is gone outside the high voltage battery. Of course, we cannot shut down the high voltage battery. We just can disconnect safely the high voltage battery from the rest of the high voltage system, what we have done right now. So now I can get rid of the glass, and now I quickly have to pick up the insulation measuring tool. You can stay there, because now we remember the fault from the beginning. We have the insulation fault there. And now we have to measure it with a special tool. So I'm back again here. We have now a special tool where we can measure the insulation resistance. So, okay, we're talking about that we want to measure resistance over here. When we now go to the ohm meter, we see now, okay, here we could measure a resistance. But the problem is we are speaking in terms of insulation about a very, very high resistance. This is why you cannot use a normal ohm meter, because it cannot show this high resistance, which are not recommended, which you need to have in order that the system is fault-free and safe. That means we have to operate with a very high test voltage with which the system will measure the voltage. So we have a nominal voltage of that system around about 500 volts. So then we can go to a test voltage of 500 volts as well. So there you see it right now. I hope. Perfect. So there we see we have 500 volt activated. So it's also, and that's also a common mistake. Now we have also to switch the connection. So we have to go over here. Otherwise you will measure nothing. So when we now go to test, we will put out 500 volts on the system in order to measure the resistance. And this is what we will do now. We will now, it's pretty easy over here. We measure against the ground of the car, of the chassis. And now we will see what the system will tell us. And there we see already we have a much too low resistance. So we just have 0.3 mega ohm, and it should be much, much, much higher. So that means it doesn't matter where we measure here, because everything is connected with each other. We will find the problem everywhere on these measuring points. So the next step would be now, okay, we have a problem maybe at the inverter, at the cabling, or at the motor generator, and we have to take out or disconnect everything from each other, and at the real car do a measurement for each thing individual. We don't do that here because this is individual for each car. So what we have done here is for each car the same, but from that step on, it's individual for each car. And this thing you have to do then on the individual car. So there is a BMW would be different than an Audi or a Toyota, for example. So very nice. When I'm deactivating the fault, and I will do the measurement, there you see now, we have far above 550 mega ohm. So we have a higher voltage, we have a higher resistance than the measuring tool with 500 volt measuring voltage output can measure. So this would be the okay status. And you see, I've just have deactivated the fault, and then we are back again in normal condition or good condition. So there, now what we have basically done is we have measured the most common fault on high voltage cars. In order to put everything back, or we just have to put everything back, delete the fault code, and then everything is good. Okay, good again. But we won't do that right now. For now, we just want to jump over to the high voltage battery trainer and have a look at this system then. So, because here, like I said, this would be when we're coming from that system, the next step would be that system. So this system is not, we have focused before everything outside the high voltage battery, and now we will focusing inside the high voltage battery. I just also, I have to go stop here, right? Dela?
Yeah,
perfect. And just switch over to here. Yes. So you see again, LabSoft again, same learning environment, different course. So what have we here now? Like I said, we have here a real high voltage battery, and everything is focusing this high voltage battery in that course. We have 16 lithium ion cells, which are specially designed in order that they can be used as a training systems. So you don't need to worry about safety aspects. Everything is absolutely student safe. You don't have to worry about short circuit problems or anything like that, or that they can discharge too quickly and be broken. Everything is designed that way that they are very durable for a training system. And again, here we have an integrated measurement interface like at the other car train. 4-channel oscilloscope is with us on board. We have the different charging infrastructure here. And of course, we have up here the different points which are important for the car in order to start it. So what are we doing right now? We have our brake button over here. Do you see it? Yeah, it's left hand beside the wheel. So there we simulate just a normal brake, like you would push the brake pedal with your foot. And we have here our engine start button. I think you have to go a little bit higher. Yes, exactly. So if we are just pushing that now, what we are doing, we are just switch on the ignition. In order to get the ready mode again, which we have seen or got to know by the other system, we have to push the brake and then start the high voltage system. And there we see the state of charge of the battery. So this is the real state of charge. This battery is at the moment charged to 93%. And we are in ready mode. That means we can now start driving. But before we do that, I open now, and this is the very powerful tool even here. We have our tester. So here we have created a complete diagnostic manufacture tool which comes together with the e-learning curriculum of that training system. And here we can go very deep into the diagnostic like you can do it on a real car with the car manufacturer's diagnostic tool. So we switch to the high voltage system. And first we start now, because right now everything is okay, we start with the system values. And we have here the cell voltage monitor. And this is now a very cool thing, because what you see here is now the voltage of each single cell. Right now we are just in ready mode, so no current is going into the battery or is leaving the battery. But now what we are doing now, we accelerate now the system. And now we are driving uphill, shown by this LED stream, which goes more or less uphill here. Inside the diagnostic system, you see now left bench, right bench of the high voltage battery. And there you see now that 4 amperage is going out of the battery. So we are discharging now and putting load on the cells through discharging. When we would run the system like that, the battery or the state of charge would go lower, lower, lower until it reached 0%. So now we go from the uphill mode to driving on flat terrain. So there you see the change now in the current, which is leaving the high voltage battery. We are jumped from 4 to 2.6 right now. And then when we go a step further, there we even have 0. So nothing is going in and nothing is going out. So what does it mean? We are now in the coasting mode. The car has seen that no one is accelerating and we are on flat terrain. So it just let the car roll and will just kick in again when the speed is decreasing too much. And then we were driven up the hill. Now we have to drive down. That means in the first step, we have now a normal or the low level recuperation. That means we're just rolling the car down the hill. And there you see now 2.7 or 1.6 or 1.7 amperage is going back into the battery. So now we are charging actually the high voltage battery cells again. When we going to level 5, we have even this depending on the system, because we have a very high state of charge now, up to 92%. It doesn't let us to do more recuperation. When we would have been now to 50%, now even the value would go higher, because now we have even increased the brakes. So now we do not just let the... Okay, sorry. Now we do not let it roll. Now we even use the brake. So that means we use the brake system in order to increase the recuperation and the braking force, and we would recuperate more. So that is all what you can see with this tool. You can also jump to the cell temperature. There you see from the single temperature cells all the different values over here, and you see what kind of temperature is inside the high voltage battery. Very important to see if there is a critical problem, because when we have a temperature problem inside the high voltage battery, we can also always assume that this is pretty critical. Okay, right now everything is okay. But yes?
Sorry, just to interrupt there. It looks like we're already 10-15 minutes over the time allocated.
Oh yeah, you're right.
Does everyone have time to continue, or do you have any questions? Because just in case there's some time to ask some questions as well.
I just talked to our agent. He's with all the guys, so most of the lectures have to leave in around 10 minutes.
Okay.
Maybe you can summarize shortly, and yeah, then we can ask some questions if they arise and finish for today.
Okay, perfect. Then just what I want to say right now, because yeah, this is a topic where you can talk so much. We have here our diagnostic job orders directly inside the course. So same like with the engine management car trains, you just go inside the chapter, and you will activate a fault, and you have above 20 different faults here, from very easygoing faults which are easily to find, up to faults inside the cell where you have to take out the cell and replace it against a new one, basically, or see where the problem is inside high voltage battery. And very important, now we see we have now an activated fault. Now we have to shut down the system again. We won't do that right now because of the leakage of time. But here you won't do it in the classical way like we've seen before. Here you would use the tester again. And I just quickly jump to it. Here we have a special function, and here we would use the high voltage isolation procedure through the diagnostic tool. This is much easier to do because we don't need any gloves, because we do not get in touch with the high voltage system. Here we are just following the pages and the hints of the car manufacturer inside the diagnostic tool. And basically how we shut down the system here is over that little switch, which we have to pull out and secure it by a padlock again. And then everything else, the car will do it itself. It will measure the high voltage and tell us, okay, it's dropped down to a safe level, and then we can start working on the high voltage system. This is the most common way what we are doing right now today on today's cars. So this is the classical way. Older cars, where also a lot of on the road, have the shutdown procedure with the high voltage service plug. Nowadays, the cars normally just use the low voltage service plug, and just in a very urgent case, they drop back to the orange one. And if I have now shut down the system, like by the help of the tester, I have to wear again my gloves, and then I can dismount disassemble the complete high voltage battery. Okay, so far here, I stopped the screen share. You did it? Okay. Okay, are there any questions right now? Or Sebastian, maybe you take the lead now. What is important? Is there any feedback, any questions?
I don't know whether they have installed a microphone, but if there's...
They can switch on the microphone, of course, right now, even, and say it directly.
I'll just put it in chat if they don't have a microphone.
And when you don't have a microphone, of course, you can put it in the Q&A section there.
Okay, I would suggest that you briefly summarize the whole session, that we come again from the basic system to the advanced systems, the Lucas-Nuelle concept, just in 2 to 3 minutes, and then I guess we can finish the session for today.
I can just show a quick screen of the progression there, Sebastian, as what Christian's just shown. I have a very quick view on what that looks like, if you wish.
Yeah, go for it.
So I'll just share my screen. So this is looking at some of the of what a workshop might look like in this field. So combining all of the Unitrain that you've seen before together with the car train systems. This here is a specific laboratory for hybrid electric vehicles, but the concept is the same across all different systems. And you can see how the system is designed to be all of the students working together at the same time with the teacher. They're working together. But the way Christian explained it before, with the desktop system, the Unitrain is where the students might learn the fundamentals. Putting that together with a car train to understand how the whole systems work, so that when the student is ready for or have completed all of those, it's kind of like the student is then ready for industry, essentially.
Absolutely. And all over that you can put, especially for the hybrid electric vehicle section, you can put that umbrella of the IMI with the different EV qualifications, where the students get something in their hands for the market, that they are high voltage experts. But this is like, that's directly going on top to that explanation what Daniel just did. So thank you for that. So Sebastian, do you have any points left open which are important to mention?
I guess if there are no questions from our client, yeah, I thank you for your presentation.
But you can also, you can, when you have still questions, just write it in. We can answer them by email, so they won't go away when you are leaving.
Sorry, come again.
So I just said, when you have still questions and you don't have the time, just type them in. We see them, and then we can later answer them by email. And we can even maybe send around all the IMI brochures, which explain that in a little bit more detail.
Okay, again, thank you very much, Christian. I will follow up with him, and if there are any more questions needed or support from you guys, I'll let you know.
Yeah, finish.
Okay.
And like my colleague just said, everything is recorded. This will also be uploaded to YouTube. So you can show that to your colleagues or just have a look at it again. And there are also other videos without showing the other systems a little bit more detail. So if you are interested in that, just maybe Sebastian can put these links as well into the feedback email, and then you have access to all the different videos as well.
Perfect. That's a great idea. Thank you very much, guys.
Yeah. Amazing that you were here. Like I said, if you have any more questions, just type it in, send it to us. We are happy to help. And I hope you enjoyed this webinar today, and have a great day.
Thank you. Thank you. Thank you. Good information and good training. Thank you.
Very nice. Thank you very much.
Great presentation, Christian and Della. Thank you.
Thanks.
Thanks, mate.